Okay, we should now be able to predict what kind of solution we get when we dissolve a particular salt in water based upon whether or not the parent acid is called the acid that could form, and the parent base, the base that could form, who's stronger. Who's stronger produces that kind of solution. So if we have a salt like sodium chloride, which could produce sodium hydroxide and hydrochloric HCl, hydrochloric acid, those two are both strong. So we should get a neutral solution out of that. Let's take a look at problem number 4, which has this salt here, sodium, ammonium chloride. Ammonium chloride dissolved in water. It says it's a solution, and we know that it's a solution because it has a 0.42 molar, we should write that in there, 0.42 molar concentration, which we know is a solution. So we have this salt dissolved in water. What kind of pH should we get? Should we have a neutral pH, an acidic pH, or a basic pH? And actually the question's asking exactly what is the pH, so we're going to have to figure that out. But let's make a prediction. Let's predict what we should get for a pH. All right. The ammonium is going to want to connect with OHs. The chlorine is going to want to connect with hydrogens. All right, let's see. Yes, it's one of the 7 strong acids you just got to know. Strong acid. Weak base. That is not a group 1 or group 2 metal, so it's a weak base. So what do you have? You would have a strong acid, weak base. Strong winds. We should get an acidic solution, so a solution with a pH less than 7. And let's go ahead and do the math and find out if that is true. Okay, so what's going to happen is this gets dissolved in water, separates into our ammonium and chlorine. And as we said earlier, that the chlorine is going to want to hook up with H's, but it can't. So that just doesn't happen. So you're going to have H's floating around with the chlorines, and they want to get together, but the water says, you shall not pass. It can't happen. It won't happen. But what can happen is that some of this NH4, which is floating around, okay, and it's weak, so you will get some of that connecting with OHs, but not all of it. And so some of it's going to end up breaking down. The NH4 will break down to form NH3 plus hydrogen. Now we predicted that this should, because strong beats weak, strong acid be the weak base, we predicted that this should give us an acidic solution. We are going to have hydrogens floating around in here, okay? Because it's going to, this is going to do some partial dissociation and cause those H's to be given off. So we should have more H's, and therefore we should have an acidic solution. Now initially, I was given the concentration of this. So this to break it apart. This is a very soluble salt, by the way. If you got to remember from Chemistry 1 a long time ago, and you probably don't, but in case you might, maybe you do. But the ammonium is always soluble, no matter who it's connected with. Soluble. Chlorines, that's from the halide group. Soluble 92.3.7% of the time. I made that up, but it's pretty soluble. So these two together make a very soluble salt. So this breaks down completely. You get this. Some of this breaks down into this. So initially, I will have 0.42 molar of that, of the ammonium. So as that breaks down, it starts out that I don't have any of this, and I don't have any of that. So the change over time, we're going to lose some of this. We're going to make some ammonia, and we're going to make some hydrogen ion. All right, 0.42 minus x. X. Let's do the K calculation. Oh, we love K calculations, too. K calculation. Now, the K value for the ammonium should be given. If it's not, we gotta go look it up. Yeah, I'm gonna go look it up. I'm so good to myself. Here it is, right there. 5.6 times 10 to the negative 10th. 5.6 times 10 to the negative 10th is the K value. So 5.6 times 10 to the negative 10th. And I'm assuming at this point that we've done so many of these K calculations that we remember that K equals products over reactants, okay? So that's the K value for the acid. And these are my products, which are X and X. So I'm just going to put that in as X squared, products multiplied, Xi, over the reactants, 0.42 minus X. And that X is going to be so small, we're going to get rid of it. Now remember the rule of 100. The reason we can do that is because if we take the initial concentration, 0.42, and divide it by 5.6 times 10 to the negative 10th, well, that's a really small number. You're going to get a huge number greater than 100, which means that X is small. Bye-bye. Gone. All right, let's solve for X. Let's go ahead. Cross multiply. We're going to take the square root. Okay, multiply, take the square root. And if you do that math correctly, they did it out earlier here, so save you some time. Again, if you don't believe me, you should never believe somebody who wears a nautical shirt. My nautical shirt. Don't believe people like that. Let's see, what do we get? That X comes out to be 1.49 times 10 to the negative 5th. 1.49 times 10 to the negative 5th. Okay, that's X. Well, what is X? X is ammonia and the H's. What's that? H is partying with H is partying, yeah. That's the Friday song, but I made it a hydrogen song. Rebecca Black. Awesome. Okay, so that is the concentration of H. Now remember, these are concentrations. Concentration of H at equilibrium. We all remember the pH equation, and you need the concentration of H, and we can now figure that out. The pH is equal to negative log times the H concentration, which is right there. So that is 1.49 times 10 to the minus 5. So go ahead, get that on your calculator. Your log button. All right. I know your calculators are different, so they work differently. Sometimes I hit the log button first, sometimes I hit it second, but mine goes log 1.49, second function exponent negative 5, enter, boom, and you get a negative value, which is why the negative is here. To cancel out that negative, give you a positive pH value. And that pH should come out to be, drum roll, because it better be acidic. It better be, because we predicted it would be acidic. We predicted that the strong acid over weak base wins. Okay, let's see, it comes out to be, yes, 4.83. Score. And you do a happy dance. Because chemistry makes so much sense.